Hello everyone, my name is Wang Xu from City University of Hong Kong. My supervisor is Dr. Chen. The topic of this poster is understanding the limitations of InfoNCE. This work is also going to be presented at InfoNCE 2022. Mutual information can be defined as the key divergence between the joint distribution Pxy and the major distributions Pxpy. The problem is that if we have only access to limited samples drawn from Pxy, how can we estimate the mutual information between x and y from these limited samples? One type of estimator is called classifier-based mutual information estimator. We can define mixed distribution P tilde Y tilde given C, where C is a discrete random variable, and by Bayesian theorem, we can estimate the test ratio by this posterior distribution P of 1 given xy. And then we can have this MR estimate. Another type of MR estimator is called mutual information rational law bounds. For example, if CE can be defined as this formula, where y prime is distributed at py and it is independent with x. There are many limitations of InfoNCE. If we have ID samples, we can have this empirical estimate, but this estimation suffers from log-in curves, which means the supremum of this estimator goes to log-n almost surely when y contains continuous component. For example, if we consider the joint Gaussian distribution with rho equal to 0.9, and we have 400 train samples, we can see that the MR estimate of InfoNCE always converge to log-n, no matter what the direction is. And if we exclude dead samples from reference samples, the estimator will no longer suffer from log-n curves, but it will suffer from another issue we call overshooting problem. The supremum of this estimator is unbounded if y contains continuous component. And we can see that the MR estimate have no sign of convergence sign, any sign of convergence during the training. We can say that it include or exclude the samples from reference samples will lead to log-n curves or overshooting issue. So the core idea is that we can smooth out the training objective to control the weight of samples and allow all the dead samples, the reference samples, appear in both terms of InfoNCE estimator. We first introduce level C and define x to the y tilde just as the classifier-based models, and we can have the following smooth InfoNCE estimator. This is a new variational expression of MI. Empirically, we can let the P of C given 1 and PC of 0 as 1/2 and construct the data set of x tilde y tilde by repeated dead samples n-1 times and merge with the reference samples. And then we can have this empirical estimator. We can show that the smooth InfoNCE can provide final MR estimate without overshooting if we apply soft levels. But our model still have the drifting problem, which means suppose T star can achieve the optimum value, then any T prime defined as T star plus some constant shift can also achieve the same value. To further reduce the variance and overcome this problem, we propose to regularize the normalization constant to be 0. And for fair comparison, we apply the same trick for all the models in this work. We can see that we test the dimension 20, 40, and 80. The our model can provide reasonable estimate for all these cases without overshooting. And this is the heat map of our model and the controls. And this is the InfoNCE and the InfoNCE with exclusion. In the future, there are many types of regularization forms can be used to help speed up training. And another research direction is that we need to understand the relationship between the optimal emission estimate and the smoother levels. Thank you for listening.